Alright, today we're going to do the 2A review worksheet. This is part 2. We're going to start at 14 and see how far we get. So number 14, we have 9x squared minus radical 2 times the quantity 9x plus radical 2, all equal to 159. The first thing we have to do is we have to do PEMDAS, as we have to simplify. So before we solve, we have to simplify, which means I'm going to use FOIL, which means first, outside, near, last, or I like to call it double distributive property, whatever. So the 9x is going to go to that 9x, and together that's going to make 81x squared. Then that 9x is also going to go to that radical 2. Notice the 9x is not in a radical. The radical 2 is in a radical, so they cannot be combined inside the radical. So it's just going to be plus 9x on the outside, radical 2 on the inside. All right, can't mix them together because one's out, one's in. Same thing here with the inside. Radical 2 times 9x becomes minus because of that minus right there. And 9x is on the outside, radical 2 is on the inside. Then we have radical 2 and radical 2. Notice the minus is on the outside, so it stays on the outside. Both of those are inside, inside a radical, so you can multiply them together to get 4, all equal to 159. Now I'm going to combine like terms. Those are the same thing except opposite signs, so they cancel each other out. Another way to look at it is I can combine them because they both have the same radical. So those cancel out. I'm left with 81x squared. Radical 4 turns into 2, so it's minus 2 equals 159. Now I just use PEMDAS backwards to solve. So I get rid of the subtraction first, that's why I add 2 to both sides. I get 81x squared equals 161. I divide both sides by 81. So then I get x squared equals 161 all over 81. I square root both sides. So I get x equals plus or minus the square root of 161 all over 81. Now, I can't leave this as a fraction because you're not allowed to have a fraction inside the radical. Remember, the radical has to go to the top and the bottom. So it becomes x equals plus or minus radical 161 all over radical 81. And this is going to work out nicely. We don't have to do anything with conjugates because radical 81 is perfect. So my final answer becomes plus or minus radical 161 all over 9. You want to make sure that radical 161 can't be broken down. If it could, you would. All right? Moving on. All right, number 15, we have the square root of 3x plus 12 equals 6. This is, once again, since there's only one variable, I'm going to use PEMDAS backwards. Now what I need to remember is how do I get rid of an exponent? The exponent, you get rid of it by a radical. The reason this is a double arrow is because a radical can be eliminated using an exponent. So the first problem that I want to do is I need to get rid of this radical here. So to get rid of the radical here, I actually square the left side because that makes this check mark, this is the radical sign, and the 2, they'll cancel each other out. And if I square one side, I have to square the other. So the radical and the little 2, they cancel, so I'm just left with 3x plus 12, all equals 36. I subtract 12 from both sides. I get 24. I divide by 3. I get x is equal to 8. Now the one thing I do have to do, because there's a radical there, I do have to plug that back in and double check, because it is possible that that doesn't work, and that there's no solutions, even though mathematically it does say there's a solution. So I'm just going to check it. 3 times 8 plus 12, that is the square root of 36, is equal to 6, so it does work out, so this one does work out perfect. All right, moving on. All right, for 16 through 23, we're going to be factoring. And factoring Factoring is going to have this little flow chart. That's kind of the hint sheet I gave you to tell you what to do. So the first thing whenever you're factoring is you always look for something in common, because if you can make it smaller, it's usually going to make factoring a little bit easier. So if there's something in common, you factor out that common term. If not, you don't do anything. So once you look for something in common, whether it's yes or no, once you do the factoring, you ask yourself, how many terms are you left with? If there's 3 terms right here, you follow these steps. You write the factors of the first term, then the factors of the last term, and then you check the middle using FOIL. We're going to talk about a shortcut when we have 1x squared. If there's only 2 terms, you're going to look for perfect squares, and there has to be a subtraction sign in the middle. If there's not a subtraction sign in the middle, you're not going to be able to do anything. Right? If there isn't that, you're going to be looking for something in common. And if that doesn't happen, there's really no option. It's probably not factorable. All right, so number 16, we have x squared minus 16x plus 63. There's 3 terms. So I'm going to follow those steps for 3 terms, where I write the factors of the first term. How do I get x squared? Well, the only way to get x squared is x and x. And then how do I get 63? I can use 63 in 1. I could use 9 and 6. I meant to say 9 and 7. So those are my 2 options. Or in reality, I also could do minus 63 in minus 1, or I could say minus 9 and minus 7. Okay. Now there's 2 ways to do this. You could always check using FOIL, so you could write out a couple options. And then you could pick any of these sections over here. You could pick this set, this set, this set, or this set. And then you do the outside, or you do the outside and the inside to see if it gives you what you want in the middle. But because this is 1x squared, because that's 1x squared, you can actually just add these up. You say 63 and 1, that gives me 64. It's not equal to negative 16. So then I know I'm not going to use that one. This is going to give me negative 64. Notice, when you change both the signs, it just changes, the number stays the same, but the sign changes. So when I see I have 16, I want negative 16. So all I do is I change both sides, and look, if I look here, it does add up to negative 16, and that's what I want. So since that's what I want, I just write minus 9 and minus 7. And this is your factored form. Your factored form is 2 sets of parentheses, so it's x minus 9, x minus 7. All right, moving on. All right, 17. I look at 17, I have 9x squared minus 81. That has 2 terms. A lot of people are going to just start and use it just like with 2 terms, but the first thing I'm going to do is I'm going to look for something in common, because that's going to make my life easier in the end. And I notice that both 9x squared and 81 can be divided by 9, so I factor out that 9. That leaves me with x squared minus 9 inside the parentheses. Now inside the parentheses, I still have 2 terms, and they are both perfect squares. So since they're both perfect squares, I get to use this formula, a squared minus b squared. If you have a difference of perfect squares, perfect square minus perfect square, with subtraction sign, you get to write it as a minus b, a plus b. So x squared is perfect because it's x and x. 9 is perfect because it's 3 and 3, and there's a subtraction sign in the middle. So I keep this 9, that 9 drops down, and this parentheses turns into x minus 3, x plus 3, and that's your final answer. All right. Moving on. All right, 18. I look at 18. I have 3 terms. So then, I'm going to break down the factors of the first term, 5x and x. I'm going to break down 6. Could be 1 and 6, or could be 3 and 2. It also could be, although very unlikely because I have a plus and a plus, I could have negative 1 and negative 6, or negative 2 and negative 3. All right. So now I just write out my options. I could have 5x and x, or maybe x is first, because once I have something other than 1 out front, once I have something other than 1x, the order matters. So order matters. All right. So first thing I'm going to do is I'm going to just check 1 and 6. So I check 1 and 6. I get 30x, 1x, together that's 31x. That is not 17x, so there's no way 1 and 6 is going to work. All right, I'm going to try it with when maybe they're different spots. I get x and 6, that's 6x, and 5x, together that's 11x, also not 17x. So I know 1 and 6 is not going to work no matter which method I use. So maybe I'm going to try 2 and 3 and 2 now. So I try 3, I try 2, I try 3, I try 2. I get the outside, I get 10x. The inside, I get 3x. Together, that's 13x. 13x is not equal to 17x, so that 3 and 2 doesn't work. 5x and 3x is 8x. X and 2 is 2x. Together, that's 10x. That's not 17x. So that one's not going to work. I try it with all the negatives. The only way the negatives would work is if I had the same number but different signs. So if I were to have negative 10x there or negative 13x there, I would switch the sign. So I know those aren't going to work. So what I'm going to say is this is not factorable. I tried all the options and none of them worked. All right, moving on. All right, number 19, same concept. We have 3 terms. It's a lot easier than 18 because both the first term and the last term are prime. So the only way to get 3 is 3x and x. And the only way to get negative 5 is negative 1 and 5, or 1 and negative 5. Now once again, I don't have to write both of these down because I know if I get the right number but the wrong sign, I just flip the signs then. So I'm only going to actually check one of these. So I check 3x and x, and then I'm going to put minus 1 and plus 5. 3x and 5, I'm checking the outside, I get 15x, minus 1x, together, that's 14x. That's what I want in the middle, so I know this is my final answer. All right, number 20, once again, has 3 terms. So I'm going to break down the factors of the first term, that's x and x. I'm going to write down the factors of the last term. There's a whole bunch of factors here. I have 1 and negative 132. I have 2 and negative 66. I'm going to have 3 negative 44. I'm going to have 4 and negative 33. I'm going to have 6 and 22, negative 22, or 11 and negative 12. Now I see if any of these, because it's only a 1x squared, I'm going to use my shortcut and see if any of those add up. I see that 11 and negative 12 adds up to be negative 1. So that's going to be my answer. X plus 11, x minus 12. And that's it. All right, 21. Do the exact same concept. 21 is a little bit more difficult because 12 has a bunch of factors and 15 has some factors. So it's going to be a little bit more difficult. It still has 3 terms. So I do everything exactly the same. We'll break down 12. How do I get 12? Well, I could have 1x and 12x. I could have 2x and 6x. I could have 3x and 4x. 15, because it's positive, I could have 1 and 15. I could also have 3 and 5. I could also, in theory, have the negatives, but because it's a plus and a plus, the negatives aren't going to be involved. All right? Now, in all my experience, I've just always had the most success trying the numbers that are closest together. So I'm going to try these ones first. That doesn't mean that they're going to work. It's just that's what I've had the most success with. So I always try the numbers that are closest together first. So I write 3x and 4x. And I actually write it twice. But the difference is I write the order different. Because order matters when we talk about factoring. So I'm going to try 3 and 5. Try 3 and 5, and 3 and 5. So I check this one. I get 3x and 5, that's 15x. 3 and 4, that's 12x. Together, that's 27x. Not going to help me. Check this one. 4x and 5 is 20x. 3 and 3x is 9x. So together, that's 29x. And that's what I want in the middle. So this is my final answer right here. So that time I got lucky. It just worked. It's not always going to work out that way. It's not always going to be that the numbers that are closest together always work. Just in my experience, they seem to work. Seems to save me the most amount of time. So that's 21. All right, 22. Once again, I have 3 terms. This is an easier one because there is a 1x squared. Since there's a 1x squared, I get to use that little shortcut, so I know x and x. And how do I get 32? Well, negative 32, I have negative 1 and positive 32, negative 2 and 16, negative 4 and 8, all right, and I look and I see that negative 4 and 8 gives me positive 4. I want a negative 4. So all I do is switch those signs, and it gives me my correct answer, x plus 4, x minus 8. There's my factored form. So that was one example where if you have the same number, but different sign, switch both signs to get what you want. All right, that's what I did there. Moving on. All right, 6x squared minus 41x plus 44. It has 3 terms. So I'm going to follow those rules that we talked about before. How do I get 6x squared? Well, I could have 1x and 6x. I also could have 2x and 3x. 44. I could have 1 and 44. I could have 2 and 22. I could have negative 4 and negative 44. Or I mean positive 4 and I could have 4 and 44. Because I have a positive here, but a negative in the middle, that means I think all these are going to be negative. Because a negative and negative will give me a positive. That's the only way it's going to add up to be a negative. All right. So once again, I'm just going to go through my normal habit of I always check whatever numbers are closest together. So I'm checking 4, and it's not 44. It should be 11. I don't know why I said 44. That should be 11. And actually negative 11. So I'm going to check the numbers that are closest together first. So I just write this twice, 2x and 3x. And then I write 3x and 2x. All right, I'm going to try negative 4, negative 11, negative 4, negative 11. I check the outside. I get 2x minus 11, that's minus 22x. I check the inside. Negative 4 and 3 is minus 12x. Together, that is minus 34x. It's not what I want, so I know that's not right. Check this one. 3x and minus 11 is minus 33x. Minus 4 and 2 is minus 8x. Together, it's minus 41x. That's exactly what I want. So that's my factored form right there. That's my solution. And like I said, I just got lucky. All right. Moving on. All right, next page coming up is a little bit easier. 24. I have two sets of parentheses being multiplied, so you're either going to use FOIL or you're going to double distribute. They're the same thing, whichever one you want to look at it. I think double distribute is a little bit easier, so I just say x goes to x, then x goes to 5, so x times x is x squared, x times 5 is 5x. Now negative 3 goes to x, so that gives me minus 3x, and then negative 3 goes to 5. Gives me minus 15. Combine my like terms, I get x squared plus 2x minus 15, and you're done. Okay, that's all there is for that one. All right, 25. 25, exact same concept. I'm going to use FOIL or the double distributive property. I used double distributive property this last time. I used FOIL this time. FOIL is 5x times 11x because those are the first two terms you see. That's 55x squared. The outside is 5x plus 8, or times 8, so that's 40x. The inside is 2 times 11, that's plus 22x. And then the last is 2 times 8, that's 16. Combine my like terms, 40 and 22 becomes 62x. There's nothing to combine x squared with. And there's nothing to combine 16 with. So that's your final answer right there. And that's all there is for 25. Alright, 26 looks a little more difficult just because there's an extra set of parentheses. So the real trick is you just pick 2 to start. So I just picked 2 just like I did in the last two problems. So I'm going to distribute those. X goes to 2x, give me 2x squared. X then goes to 1 to give me x. Minus 2 goes to both, give me minus 2x. Then minus 2 goes to 1 to give me minus 2. I didn't do anything with this x minus 4, so it just drops down. And technically I put everything in there in parentheses. The x and the minus 2x, those get combined. So I have 2x squared minus x minus 2. All times x minus 4. Now I'm going to use the distributive property. I like using the smaller set of parentheses and taking it to the bigger set of parentheses. So I'm going to take x to everything in the bigger set. So x times 2x squared is 2x cubed. X times negative x is minus x squared. And then x times negative 2 is minus 2x. Now I do the same thing with 4. I take 4 all the way to 2x squared. Negative 4 times 2 is minus 8x squared. Negative 4 then goes to the minus x. That gives me minus 4x. And then minus 4 to the minus 2 gives me plus 8. I lined it up the way I did because now all my like terms are already lined up. So that's why I do it vertically. I didn't line anything up with the x cubed because there were no other x cubes. So I end up with 2x cubed. Negative x squared and negative 8x squared, that's minus 9x squared. Negative 2x and minus 4x, it's minus 6x plus 8. And there's my final answer right there. All right. All right, 27 is just an easier version of 26 because it's already set up in the two sets of parentheses. So I'm going to distribute using my distributive property. I'm going to take u to every single one of those set of parentheses. Every u is going to go to all three terms in the second set of parentheses. U times u squared is u cubed. U times 2u is 2u squared. And then u times 5 is 5u. 4 times u squared is 4u squared. 4 times 2u is plus 8u. And then 4 times 5 is plus 20. Notice, if you do it vertically, you can line up your like terms as you go. It makes it very unlikely that you're going to make a common terms mistake. And that's what I did. So, u cubed comes down because there's nothing to add to it. No mistake needs to be made. 2u squared and 4u squared, that's 6u squared. 5u and 8u is 13u. And then there's nothing else to go with 20, so it's just plus 20. There's my final answer. Moving on. Alright, in 28, I have 8s squared plus 7s minus 9s minus 1 minus 2s squared. This does not mean multiplication. The most common mistake I see in this problem is somebody tries to multiply. And the reason they do it is because they see a problem like 24. The only multiplying you can really do is you can say, I'm going to multiply that negative by everything and change the signs. Or you can think of it as I'm going to just add the opposite. So there's nothing in front of this first set of parentheses, so the parentheses just go away as 8s squared plus 7s. That negative sign just changes everything in this set of parentheses, so that 9s becomes minus 9s, that negative 1 becomes plus 1, and that negative 2s squared becomes plus 2s squared. Now I just add up like terms. 8s squared and 2s squared is 10s squared. Notice I cross them out when I'm done so I don't accidentally use them again. 7s and minus 9s, that becomes minus 2s. Cross them out when I'm done. The only thing that's left is plus 1, so plus 1 is my final answer. Done. 29 says just simplify the radical, so you're going to look for perfect squares that go into 27. The only ones you really care about are the ones less than 27. You ask yourself, do any of these numbers go into 27? I always start at the bottom. Does 25 go into 27? It doesn't. Does 16? Nope. Does 9? It does, because 27 can be written as 9 times 3. Now I ask myself, which one of these two is perfect? 9 is perfect. The square root of 9 is just 3. That's why this 9 comes outside as a 3. This 3 right here stays inside the radical forever. That's that 3 right there. All right, so your final answer is just 3, radical 3. All right, number 30. Number 30 is an easier version of number 28 because there's not a negative sign in between the parentheses. There's a plus sign, and that makes the parentheses just go away, and you add up like terms. So there is no parentheses because that plus sign doesn't do anything to anything. There's nothing in front of this one. So it becomes 5x squared plus 6x minus 2 minus 12x minus 2. Notice it didn't change it at all. It didn't make a positive. It just kept everything exactly the same. Now I just add up my like terms. Is there any other x squareds? Nope. So I just write 5x squared, and then I cross it out so I don't actually use it again. 6x minus 12x, that becomes minus 6x. Cross them out so I don't accidentally use them again. Minus 2 and minus 2 becomes minus 4. So my final answer is 5x squared minus 6x minus 4. All right, 31. 31, the first thing you need to do before you do anything else is you're not allowed to have that negative inside the radical. So whenever you see a negative inside the radical, it leaves as I. So the first thing I do is I make this I radical 396. Now I'm looking for perfect squares that go into 396. 1, 4, 9, 16, 25, 36, all the way down to 256. I start at the bottom and I work my way up. And as I do this, I find out that 396 is broken down into 36 and 11. 4 is going to work too. If you use 4, you're going to have to actually break it down a second time. So if you use the biggest perfect square, so you're going to use the biggest perfect square factor. All right, 36 and 11. So 36 comes out I get 6i, and then 11 is not perfect, so it stays in forever. And that's it. That's your final answer. That finishes this video, so thanks. So that finishes this review worksheet. Part 2 is 14 to 31.